Group 11 welcomes you to the course Chemical Engineering Drawing, and throughout this course you'll be taking a look at the introduction to the course, the importance of the course, the fundamentals needed, the symbols and conventions used in chemical engineering drawing, piping and instrumentation diagrams, process flow diagrams, equipment layout drawing, and the dimensioning and tolerancing used in chemical engineering drawing. So chemical engineering drawings, what are they? Chemical engineering drawings are technical diagrams, so it is similar to technical drawing. You can even say it's the same as technical drawing used in the field of chemical engineering to represent processes, equipment, system, and plant layouts. These drawings are essential for the designing of plants, the construction of plants, the operation and maintenance of plants, and their related facilities. This ensures communication between engineers who are working on the plant before it is into existence and during the process of the plant operation. So let's take a look at some of the importance of chemical engineering drawing. Firstly, communication. Technical drawings in general serves as a common language for engineers, and in this case, it's being specified in chemical engineering. It allows for ease of communication between chemineers. Also, optimization. The drawing allows for thorough planning and analysis to optimize equipment layout, processes, efficiency, and safety. So before your plant is actualized, you know how the thing is going to look like. This is one of the major benefits of chemical engineering drawing. Also, documentation. We having a chemical engineering diagram of any plant we intend to bring into existence, there is a provided detailed record of the plant even before it is built, and after it is built, these records are maintained for us to go back so that we can further build on them, whether we want to expand or make adjustments when needed. What are some of the fundamentals you need in chemical engineering drawing? So, some of the fundamentals may be having knowledge on views. What are views? Views may include plan, the front elevation, the back elevation, or even perspective, as in the case of isometric or oblique projections. So there is a need for you to have knowledge of how these plans are used in chemical engineering drawing. You're also supposed to have knowledge on scales. Scaling in the sense that the actual size of objects you want to draw won't fit on the drawing sheet, and as such you will need to scale them down and you will need to know the scale of reference so that in real life scenarios you can scale them back to their actual sizes and everything will be as we intend for them to work out. Also, annotations, which may include dimensions for the symbols in the diagram, detailed notes, so that even the layman can understand the diagram when he take a look at it, and other comprehensive information. Symbols and conventions in chemical engineering are standardized graphical representations of various equipment, processes, instrumentation, and control systems in chemical engineering plants. The symbols are a lot, and we won't dive much into that. Let's look at the reason why these symbols and conventions are important in chemical engineering diagrams. Firstly, standardization. The world at large doesn't speak the same language, and for collaborations between individuals to be made possible, there is a need for a standard system of symbols and conventions which individual engineer, irrespective of their race or place of origin, can understand. Visual language. These symbols also provide a clear and concise representation of equipment in a visual manner. So immediately you see this symbol, you know, oh, this symbol represents a pump, this symbol represents a compressor, this symbol represents a heat exchanger. Consistency. Since the symbols are standard and the whole world adheres to the conventions, it promotes uniformity and understanding across different drawing and projects. And this all this importance I've listed so far helps massively in collaboration between engineers throughout the world. Let's move on to look at some of the types of chemical engineering drawing we have. We have the process flow diagrams, the piping and instrumentation diagrams, the equipment layout drawings, and others. Let's take a look at some of them. Pipeline and instrumentation diagrams, P&IDs. To better understand this concept, there is a need for us to compare it with our next topic, which is process flow diagrams. So I won't be talking much on the point illustrated here. Both of them are diagrams used in chemical engineering and industrial engineering as a whole. But for PDFs, which are the process flow diagrams, they are mainly used to illustrate the general flow of plant processes and equipment. They provide an overview of the main processes. As such, its content is mainly the major equipment items like reactors, columns, heat exchangers, pumps, main process teams with flow rates, temperature, and pressures. The detail level is not that much. It is primary and it is usually used at the early stages of process design for communication between process engineers and other stakeholders. As such, there is not much detail in it. Comparing these two, piping and instrumentation diagrams, which provide much detail and information about the piping, the equipment, and instrumentation in the process plant. The content of this diagram is made up of all equipment items with detailed specifications, detailed sizes, detailed material, detailed insulation, all other factors that is essential for the diagram. You find it in P&IDs diagrams. As such, this is usually used during the construction process of plants and they are used by the engineers, the operators, and the maintenance personnel. Since stakeholders who might not be engineers are not essential at this phase, the diagrams are detailed for the thing to be successful. Unlike process flow diagrams, where the level of detail is much lower, as such, non-engineering professionals can understand. So basically, I've explained the P&IDs and the process flow diagrams. So let's move on. Equipment layout drawings. Equipment layout drawings are essential drawings in the design and construction of industrial facilities, such as process plants. These drawings provide a detailed plan of the physical placement of the equipment within a specified area. So you have a specific plot of land, a piece of land. Equipment layout drawings show where exactly the points each equipment is going to be placed. What are some of the reasons why we use equipment layout drawings? Space optimization. Layout drawings ensures efficient use of available space and identify potential interferences between equipment and structures. Before your plant comes into place, there might be existing structures or even for your plant, there might be multiple structures, and there is a need to optimize the space between them so as to resolve any potential risks. Also, access and maintenance. If we have information on how the whole process plant is laid out, it provides information for access and maintenance. Access for users who use the facility, and for maintenance purposes when professionals come to do any maintenance work on the existing structures. Safety considerations. Since we know the layout of our plant, we can have a map for it so that individuals know the various exit routes in case of fire or any other hazards happening. Dimensioning and tolerancing, the last thing we will look at in this course. So, as you can see, it has been shown here the equipment size, the tolerance, the dimension, the tolerance, and the importance of how it should be. So, thank you for your attention, and this is the end of this course.